Welcome to Demystifying Math. In this lesson, we're going to discuss a parabola in conic form, and we're going to use the completing the square method to find the vertex of the parabola. Sometimes you're given an equation for a conic in the alternative form, where you have ax squared plus cy squared plus dx plus ey plus f equal to 0. What you're going to need to do is complete the square to find the center of the conic, or the vertex in this case of the conic. Let's begin with this example. We have y squared minus 12x plus 6y plus 33 equal to 0. In this case, our a value is 0. A is the coefficient of x squared, and there is no x squared term. C is the coefficient of y squared, so it must be 1. And d is the coefficient of x, so we have negative 12. E is the coefficient of y, so that gives us 6. And f is 33, which is our constant. Whenever you have a or c equal to 0, the graph is a parabola. So in this case, a is equal to 0, which tells us that our graph is going to open to the left or to the right. When c is positive, the graph opens to the right. Let's complete the square to find out where our vertex is. First, what we're going to do is group together our y terms and bring our constant over to the other side. So we have y squared plus 6y grouped together, and our negative 33 is on the other side of the equation. Now what we want to do is complete the square on the y terms. So we need to find a number that we're going to add to y squared plus 6y so that it becomes a perfect square. You can do that pretty easily by taking 1/2 of the coefficient of y, which we call b, and squaring it. So in this case, our coefficient of y is 6. So we're taking 1/2 of 6 and squaring it. Well, half of 6 is 3, and 3 squared is 9. Now, if we add it to one side of the equation, we must also add it to the other side of the equation. So over on the side with the negative 33, we're going to add 9 to that as well. Now we can go ahead and factor the y squared plus 6y plus 9. And that's going to give us y plus 3 all squared. And then we're going to combine our constants. So negative 33 plus 9 gave me negative 24. Now what you want to do is bring your x term over to the other side with the constant, and then factor out their greatest common factor, which is 12. So we're left with 12 times x minus 2 on the right side. So this is our equation for a parabola in conic form. Now that we have it in conic form, we can easily identify the vertex, the focus, and the directrix and be able to graph our parabola. The vertex is at hk, which in this case is going to be 2, negative 3. Remember that in your general form of the equation, you have y minus k squared, and you have 4p times x minus h. So the number that's subtracted from x is going to be your x-coordinate of the vertex, and the number that is subtracted from y is going to be the y-coordinate of the vertex. So watch those double negatives on these problems. Alright, so the other thing that we want to do is figure out what our p-value is. So 4p is the coefficient of the non-squared term. In this case, our x is not squared. So we're going to take the coefficient of x, which is 12. And set it equal to 4 times p. So that means that p is equal to 3, which tells us that our focus is 3 units to the right of the vertex. If our p-value was negative, it would be to the left of the vertex. So that means that we're going to take our vertex and we're going to add 3 to our x-coordinate. So we're moving over 3 units to the right from the center or from the vertex. So that puts us at 5, negative 3. The directrix is on the other side of the vertex, but the same distance away from the vertex as is the focus. So it's going to be 3 units to the left of the vertex. So that means that we're going to take 2, which is our x-coordinate of the vertex, and subtract 3, which puts us at negative 1. Now remember, your directrix is a line, so you need to give an equation for the line. So it's going to be a vertical line at x equals negative 1. Always remember that your directrix is perpendicular to your line of symmetry. So if your parabola opens left or right, you have a horizontal line of symmetry, which means that you will have a vertical directrix. Okay, so now we can get a sketch of our parabola. We have our vertex marked at 2, -3, and we have our focus marked at 5, -3. On the other side of the vertex, we have the vertical directrix, which is at x equals -1. Now what we want to do is find 2 more points on our graph so that we can just kind of fine-tune our graph and make sure that we have the width correct. So 2 points that are really easy to find are those that are in line with the focus. Since our focus is at 5, -3, we're going to plug 5 into our equation for x and solve for y. So solving for y, we're going to subtract what's in the parentheses first, multiply by 12/3, and we have 36. Then we're going to take the square root of both sides of this equation. Now remember, when you take the square root, you always have to put plus or minus in front of your solution, because you could have a positive or a negative that was squared. Then we're going to bring the 3 over to the other side. So that means that we have the y values could be at -3 plus 6 or -3 minus 6, which means that it could have been -9 or 3 for our y value, which gives us ordered pairs. So remember that we plugged 5 into the equation for x, and we're getting out -9 or 3. So that actually gives us 2 points that we can plot on our parabola. So I plotted them here, and you have 5, -1 and 5, 3 plotted. So that just gives you a better fit for your graph. Typically you need 3 points to complete a parabola. If you have the vertex and one other point, you can use symmetry to get the third point and solve for your parabola. Okay, thank you for tuning in to Demystifying Math.